Assalamu alaikum wa rahmatullah. Good day, everyone, and I welcome you all to our physics class today. In today's physics class, we are going to explain current density. The purpose of this class is to explain current density, give the SI unit for current density, and the formula for calculating current density. Okay, let us begin. Okay, what do we mean by current density? What is current density? Okay, in the previous video, we explained that if we have a metal wire, okay, and you cut the wire, the metal wire is usually cylindrical. When you cut it, let's say I have this my metal wire. This is a magnified metal wire. Okay, this is a wire. I made it big. Okay, we know that electric current flows through this wire due to charges flowing through the wire. Now, this is a point in the wire. I'm going to call this point P. If I cut this portion, then because it is cylindrical, the cross section is circular. The cross section here is circular. So I have a circle here, and I can get the area of this, okay, which I call A, the cross-sectional area A. Now, the current generated here passes through this, okay, passes through this cross-section here, okay. Now, if I divide this, let's say the cross-sectional area is 5 meters squared, for example, is 5 meters squared. Then I now divide this cross section into 5 equal parts. 1, 2, 3, 4, 5. Suppose I divided it into 5 equal parts so that each part here, this one is 1 square meter, this one is 1 square meter, this one is 1 square meter, this one also 1 square meter, this one 1 square meter. You see that? 1 square meter. Now, another assumption. Let's assume that the magnitude of current flowing through this conductor I is 10 amperes. I know it's a big current, but it's just for demonstration. Okay, this 10 ampere, when it flows through this point, it will be divided equally among these parts. Okay, it will be divided equally. So since we have how many parts? 1, 2, 3, 4, 5. Divide this 10 ampere by 5, and you will see that each portion will have 2 ampere. This one will have 2 ampere. This one will have 2 ampere. This one will have 2 ampere. This last one will have 2 ampere. Now add this. 2 plus 2, 4, plus 2, 6, plus 2, 8, plus 2, 10. You can see that we divided the current into 5 equal divisions for every 1 square meter area. And this means that I have 2 ampere per square meter. You can write it like this, or 2 ampere per square meter. You see that? This measurement is what we call current density. You want to know how many ampere of current is generated for every 1 square meter area of a conductor. That measurement is called current density. So it is current per unit cross-sectional area. It is defined as current per unit cross-sectional area. Okay, let's move on to define that. I don't know if you can see here. Okay, let me use here. So we say current density denoted by J is defined as current per unit cross sectional area of a material okay. In symbols, this is how we write it, that J, the magnitude of the current density, is equal to the magnitude of current divided by the cross-sectional area. Let us call this equation 1. Okay, remember in the previous video, we derived the formula for the current passing through a conductor, such as a conducting wire. Now, according to that, let's say recall that, okay, this I, we got the formula for I as NAVE. Okay, this is charge carrier density, cross-sectional area, drift velocity, and electronic charge. So it means I can substitute this for I here. Therefore, I can say my J equals, instead of I put this NAVE divided by A. You see? Now, these two are identical, so A cancel A, and I have NVE. So at the end, my current density is NVE. So you see, we have two relationships for the current density depending on what we are given. If we are given current and cross-sectional area, we just divide this to get our J. If we are given charge carrier density, drift velocity, and electronic charge, then we use the second equation. Finally, class, current density is a vector quantity. This one is a vector quantity. It's not a scalar, okay? It is a vector quantity. And the direction of our current density is the direction of this drift velocity, okay? Remember we said if current flows through here, it means this is the positive terminal and this is the negative terminal. So electrons drift in this direction from negative to positive, and this direction is the direction of our current density. So let us give a quick summary. Point number 1, current density is defined as current per unit cross-sectional area of a material, and the unit of current density, this is the SI unit, ampere per square meter. Ampere per square meter. Okay, after knowing the unit, we have two formula for it. J equals I upon A, or J equals NVE. Finally, current density is a vector quantity, it's not a scalar. Current itself, the magnitude of current itself, this is a scalar quantity, but the current density is a vector quantity. Please take note of the difference. Thank you all for watching. Assalamu alaikum.